just in case.
Oh yeah, sorry. Video.
Cool. We can see
Okay.
you. Yeah, we can see your screen. We can see yourself
Everyone.
as well. Thank you.
Okay, so let me just get the chat out. And all right, so first of all, thank you, Sasha, the Wagon, and bitgrit for giving me this opportunity to give this workshop. And thank you for everyone who's joining here with me today, and especially those who woke up super early. Kudos to you. So today, we'll be talking about data cleaning with Python, as given from the title, and it will basically be an introduction to data cleaning with Python. So my name is Benedict Neo, but you can call me Ben. I'm from Kuala Lumpur, Malaysia. I'm a third-year statistics student at ISU, Ohio State University. And I love spending my time self-learning data science and programming. And I also really enjoy reading sci-fi books. So currently, I'm an intern at bitgrit, where I'm responsible for writing technical articles. So a bit about what bitgrit is. bitgrit is an AI competition and job board platform for data scientists, home to a community of over 30,000 engineers worldwide. So what bitgrit is aiming to do is to build a comprehensive online ecosystem that aims to establish a blockchain-powered AI marketplace. It was founded in 2017. It has over 30 employees, 30,000 plus data scientist community, and 3 offices worldwide. So here's an example of the competition platform. This is a video popularity prediction challenge that was hosted this year. So in these competitions, you have real world problems to solve. You also get monetary prizes and a leaderboard feature that shows you where you're ranked when you compete. And overall, it's a very good hands-on experience that can boost your CV. And this is the job board. And you can see many open job positions here from all job experience levels. And worldwide locations will be open in the near future, but currently it's only in Tokyo, I believe. But right now it's not available because of COVID-19 restrictions. And you can find more info about bitgrit in this slide. So with that over, first of all, I'll just give a little disclaimer here. This is my first workshop, so please go easy on me. And I really hope you learn something new and get something out of this workshop. And if you have any questions at all, just shoot me a question in the chat box, and I'll do my best to answer them. So right now, let's go into the objectives of this workshop. So I want you to get 3 things away from this workshop. I want you to understand what is data cleaning and why it's important. I want you to understand what is clean data exactly, and basically just common tasks in data cleaning in Python. So there'll be 3 popular libraries that we'll be using today that use in data science. So it's called Pandas, NumPy, and Matplotlib. So first of all, Pandas, it's a data analysis library that you can use to do manipulation, such as transforming your data or creating new columns and all that. There's also NumPy, which stands for numerical Python. So what it is for is to do numerical computation, such as math transformations. And lastly, it's Matplotlib, which helps you visualize your data using plots. So these 3 are basically what you usually load out when you do any data science stuff. So right now I'll talk about what is data cleaning itself. So according to Wikipedia, it says that data cleaning is the process of detecting and correcting corrupt or inaccurate records from your data. And this refers to 4 identifications, which is incomplete, incorrect, inaccurate, and irrelevant parts of your data, which you then do 3 things to it, which is to replace any dirty data, modify them, or either just remove them from your database. So you might have heard this quote where data scientists spend over 80% of their time cleaning and just reorganizing their data, and only 20% in tasks such as analyzing it or insights and building models. I don't know if this still stands true today since we have data engineers more and more, but it's still a very important quote because it tells you that a large part of your time as a data scientist or data analyst will be spent on really making sure your data is clean. So that begs the question of what is clean data? So from the definition earlier, we can say that clean data is complete, correct, accurate, and relevant. And now I'll go into why it's important. So I have an analogy that I think it's good to understand. So let's say you have ingredients for a cake and you have a really good recipe from a top chef. But let's say your ingredients are spoiled or bad, and no matter how good your recipe is, the end result of the cake that you want to make, let's say, it's going to be bad as well because your ingredients were bad. So this is the concept of garbage in, garbage out. Basically means that if your data is bad, and if you analyze it without cleaning it or building a model with it, the end results will be bad as well because you're going to end up with misleading conclusions and conclusions. So this is bad because if you pass on this misleading conclusion to a stakeholder or business leaders, they will end up making the wrong decisions as well. And overall, this will just damage the reputation of the company and the reputation of you as a data scientist or analyst. So that's it. Right now, we'll go into the data cleaning tasks. So we'll focus on 5 main data cleaning tasks, which is renaming the columns in our data frame, converting the data types such as strings into Boolean and datetime and all that. There's also missing data, which is a very big topic we will cover. Inconsistent data such as spelling errors, or you have out of range data. And then lastly, we'll talk about outliers. So let's start now. So I have this Google Collab notebook where I encourage you all to open up as well, which I'll send in the chat now. So when you open up the link, you would see something like this on top, where they will ask you to copy it to your drive. So I recommend you to do that so that everything you run will be saved and you can have a copy of the notebook. And reminder is that you need a Google account to run this. So let's go into the Google Collab notebook right now. I'll give a few seconds for everyone to get ready on this.
Guys, so since we still have some time, I think this pose is a great time to ask any questions if you have. Just make sure that the page is loading for you. If you have any questions to Ben about his background, his studies, his interest in data science, or something that he shared before, feel free to ask. Since we have people joining during the workshop, I think, Ben, I will keep sharing your link probably every 20 minutes. So just to make sure people are on the same page with us.
All right.
Is that okay?
Yep.
Cool.
Okay. So I hope everyone is getting ready. And if you're not yet, then it's all right because I'll take a lot of time to explain and you can get it up in your own time. So when you open the Google Collab up notebook, you will see this button where they ask you to connect to Google's engine. So to explain what Google Collab is, if you don't know, it's basically a virtual environment for you to run any type of code you want and then import any kind of library all inside this environment, and you don't have to install any of the libraries in your own machine. So this is useful when you just want to experiment with things and maybe build a model or anything like that. So once you're connected, this means you can now run Python code in this Google Colab. So every time you do any data science stuff, you always start with loading libraries. So here it's a code style where I load up some libraries that we'll be using today. And if you don't know, this is basically a text file, which is in Markdown. And if you want to, let's say, update this to say something, whenever you run a code cell, you do Shift Enter, and then it will update for you. So that applies to code cells as well. So you just click on the code cell itself and then press Shift plus Enter, and it will run the code cell. So what it did was it loaded up all the libraries in the machine. So just a brief, quick run through of what all this does. So I mentioned the 3 libraries earlier. So all these are how you import the libraries. And if you see this as keyword, it just means that I named pandas as PD so that later on when I use it, it's easier to call it. Since it's a shorter name. And then there's also Seaborn, which I didn't mention, but it's basically just also a visualization library. And matplotlib inline, what it does is it plots out all the plots for us without having to call this. So it's just for convenience, basically. And this RC params figure size stands for what you think it is. It's figure size. Basically, it's a default size that I want for all my plots in this notebook. And then style is just like a theme that makes it nicer. There's also Datetime, which helps you work with date data. So with that said, I'll move on to the next section, which is called helper functions. So helper functions are functions that help you do something so that you can keep reusing that specific function without typing the code, like repeating code. So these 2 functions help me get the missing values and the memory of a data frame. So going into these functions, what missing calls does is it prints out the column with its amount of missing values along with its percentage. So let's say this is an example of the output. So column A, it's telling me that column A has 100 missing values and it has 10% out of the entire column, which is missing. And going into this code, so total equals 0. I set it so that I can keep track of what's the total missing values. And I did a for loop to loop over the columns in the data frame. And so this is how you count missing values, which I'll explain later on in the notebook. And I basically keep track of it. And then I count a percentage by taking the sum of the missing values, which is 100, let's say for column A. And then I divide by the total, which in this case, it will be 1,000 since it's 10%. And to get percentage, I multiply by 100. And then if the missing value it's not empty, that means there is missing values. It's gonna print out this customized format. This is how you format strings if you don't know in Python. So I did these curly braces are basically placeholders for any variables. And this one relates to the column names, you can see. And then this is the amount, which is this part. And then the last placeholder stands for the percentage, which is rounded to 2 decimal places. So, and I also keep adding up the missing values. And this line basically just tells me if there's no more missing values in my data frame, I'll just, it would print out this nice message for me that there's no missing values left. So if you didn't catch any of that just now, don't worry, because I'll explain more later on what these specific code mean. And for get memory, basically what it does is it prints out the size of our data frame in megabytes. So it's just like the size of a video or image, but for data frames. So running this, I've loaded up these 2 functions for me to use later on. So now we start by loading up our data to use. So the data is from GitHub, and GitHub is basically a place for you to store your code and to showcase your projects. So I have the data set right here. If you click it, and it tells you that it's taken from Kaggle, which I basically modified for this workshop specifically. So this is the GitHub can't really show big files for us. So what you do is you view the raw file, and in this link you can use it for you to load up your CSV files. And this data was from Kaggle. Sorry, hold on. So this data is from Kaggle. So it's called the New York City Airbnb Open Data. It's basically data about Airbnb housing. And a cool thing about Kaggle is all their data sets are visualized here. And you can see all the column names and data points, and even a bit of descriptions about the data so that you know more about what this data is. So we start by loading up our data. So a cool thing is Pandas can take in URLs as long as it's a file. So we take this URL, we copy it, and then we pass it to this URL variable, which we'll be using later on. So with this URL, we can call the read CSV function on the URL. And then when I press Shift Enter, what it will do is it will read up this entire CSV file onto this DF object, which stands for data frame. And I didn't mention this, but CSV stands for comma separated value, if you don't know. And what that means is all these values, you see, they're separated by commas. So that's why they're called CSV file. So we now have this data frame that we've stored, just the entire file. And let's say you want to print out the size of the data frame, which is number of rows, number of columns. What you do is you call dot, and then you type shape. So what this will mean is you're telling Pandas that you want the shape of this data frame. And running that, it will show us that the rows and the columns of the data frame. So in our case, the data frame has over 48,000 rows and 16 columns. And a really useful function for printing out a summary of data frame is called info. So this differs from shape because this is a function, whereas this is just calling the object of data frames. So that's why you don't see a parentheses, but this one is a function. And once you run it on our data frame, it's going to show you a bunch of information about our data frame. So it's going to show you the number of rows as well, and columns, the non-null count, and Datetime, and memory usage as well. So all these columns are basically the column names of your data frame. Non-null in this case means the number of rows that weren't missing. So non-null means not missing. And even from here, you can actually tell that some of the columns have missing data, because let's say for name, it doesn't match the total number of rows. So this means name has missing value. And then for Datetime, this just means the data type of your column. So name, it's the data type of an object, which makes sense because object is a string, if you didn't know. And ID is integer, which is correct. And latitude, longitude is float. Float is decimal place values, and so on. So we go into detail of data types later on. So we just move on. And if you just want to grab the data type, by the way, you can also call something just like shape, you can call dtype. And what this does, it will show you, it's dtypes plural form. What it will show you is all the data type of the columns only. So it's simpler, it's a simpler form of this, just on the data type. And let's say, because all this doesn't really show you the values of your columns, it's only the data type and the name. So if you want to have a quick peek at your data, what you do is if you call head, what this will do is show you the first 5 rows of your data frame. And from here, you can see the values of each column. And so head by default will show you 5 rows. And if you want to get more than 5 rows, you can definitely do that by passing a different integer inside the parameter. Let's say I want only 1 row, it's going to print out only 1 row for me. And so this was the first few number of rows. First few number of rows. And let's say you want the last 5 rows, you can call tail. So head is the top and tail is at the bottom, which is intuitive. And tail will also show the last 5 rows, and you can also customize it to any last n number of rows that you want. And if you don't want to just look at the top and bottom, and you want to randomly sample, which basically means you want to take a random rows from your entire data frame, what you can do is call the sample function. Sorry, that's a problem with my keyboard. Hold on. So sample function, which if you pass in 5, it's going to sample 5 random rows for you. And you can see from the index, it's randomly taken because the indexes are not in order compared to, let's say, if you call tail. So this way you can randomly sample your data frame and just look at the values. So why we use these is to look at the values and to make sure that everything is in order and the values are appropriate according to the columns. So from here, you can notice that this price column has a $sign on the values. So usually in data frames, you don't want any integer values to have a string on them because it would mess up how pandas look at this value. We want to convert it into an integer. So what we have to do later on is to remove this $sign. So we'll do that later on, but first let's deal with the column names. So I don't know if you noticed, the column names aren't very consistent. And if you want to look at the column names only, you can also call columns, dot columns, and this will show you an array of all the column names. And I said not consistent, it's because usually in column names, you want all of them to be in one word. So if you see these spacings, we usually want to remove them and replace them with an underscore. And we want all the column names to be on the same case. So name should be lowercase and not uppercase. So we'll do that later on. And if this format isn't very clear for you, you can also convert this array into a list, which you can call using to_list. My keyboard's having problems. To_list, columns, to_list, and it will print out an entire list for you. And this is a clearer format because all the columns are in one row. So what we'll do right now is to fix our column names. So these spaces, we want to replace them with underscores, and name we want to lowercase. So how we can do that is using the string methods in Python. In order to access the string methods, first we have to instantiate all these columns as a string. How we can do that is we need to call str. So this is telling Python that we want these columns to be a string. And then the method to replace values is called replace. And the parameters are simple. It's just the values that you want to replace it of. And this is the values that you want it to be replaced with, if that makes sense. I'll just show you. So the values that we want it to be replaced are the spacings, and we want to replace them with underscores. There's a problem in my keyboard, so sorry guys. Okay, so what this is, we replace all those spaces with an underscore. And in order to reduce the cases of our strings, we need to call the lower function. So all we have to do is just call .lower. And right now, all our columns are fixed, as you can see. Name has become lowercase, and all these spacings have been replaced with this underscore. So let's say if you want to do more to your column names, you want to rename it into something else, you can use the pandas rename function. How it works is it takes in a dictionary where you have key value pairs. So the keys have to be the original name, for example, name here, and the new name that you want it to be replaced with. So let's say I want to rename the column name as listing name and latitude, longitude into a shorter version, lat and long. How we do that is we call replace, and then the columns that we want to replace, we pass in the dictionary into here. And then right now, let's see that the column sorry, hold on. Sorry, it's renamed. My bad. It's renamed. So, and then we can get the column names, and it will show you that it updated, like right here. So you see that name became listing name, and then all these spacings, I mean, the latitude and longitude, it became lat and long. So, but one important thing that you have to remember using pandas is let's say I print out the column names again. It will show you that, look, it's still, yeah, latitude and longitude. Right now, it's still the original one. As you can see, name is still name. That's because you didn't use the in place equals true. So what that does is it basically updates the data frame itself based on the function. So if you don't do that, it will only be returning an output of the function and it's not updating your data frame itself. So to make it easier, you always call in place equals true if you want anything that changes onto the data frame itself. That makes sense. So the version should be Python 3. I'm not really sure the specific version. Does that answer your question, Stephanie? So I'll just move on. So right now you can see that the data frame columns, they've been updated by using the in place equals true command. So all these are some ways that you can work with the column names in Pandas, and that's actually a very cool library called PyJanitor that can do all this above in just one function, which I'll show you. So in the documentation, there's this function called clean names, which is this. So you only have to call this function itself, and it will clean the column names of your entire data frame. So that's very useful, and you can test it out if you want later on. So I mentioned just now that the dollar signs are a problem for our data, and what we have to do is remove the dollar sign label. So just to look at the data again. So in data frame, if you want to index a specific column, you just have to call df, and then you write this list where you pass in price. So the column name, which means you're indexing price of the data frame. And you can see that there are dollar signs. So how we can replace them into nothing is using the same method as earlier. We call replace. And then, so the value we want to replace it is dollar sign. So we just have to pass in dollar sign here. And then I want the dollar signs to disappear. So I pass in nothing as the values I want to replace it with. So now you see that the column, the dollar values are now all gone and it's fixed now. But now we'll be going into I'm not really sure what the question means. Camillary. Could you rephrase the question? Shortcut used to replace line. Oh, I've just been highlighting the line. So like there's a line. I've just been highlighting it. Okay, so moving on. I'll go into data types right now. So you see that our price value, they should be integers. And right now it's telling me that they're objects. So when I call dtype, so this is a singular form, it wasn't dtypes. Dtype is for a specific column. When I call dtype on my price column, it tells me that it's O, which stands for object. So a bit about Pandas data types. So these are the common ones. That's object, integer, float, Boolean, datetime, and category. So right now our price is in an object or string category type, string data type. And we want to convert it into integer. So how we can do that is using the Pandas to numeric function. So to go into this code cell, so we call pandas.toNumeric, and then we want to pass in the column that we want it to convert it into a numeric. And by passing this, you can see that the data type now is an integer. So we've updated it from an object into an integer. And looking at the data again, you can see that right now it's fixed. And if you want to view the D types of all the columns again, you just call D types. So moving on to the other columns, we also have to check whether some of the data types are in the wrong data type. So for example, these three, neighborhood group, neighborhood, and room type. So going to the Kaggle documentation, they are actually categorical data because if you see, it's all categories of Brooklyn, Manhattan, and so on. Neighborhoods are also categorical as well as room type. So that's it. We want to convert it into a category, but there are some guidelines that when you work with category data types, firstly, it's usually convert it so that it can reduce memory and increase performance with some of the operations related to categorical. Yeah, sure, SD. Related to categorical data. And then you also want to make sure that the data is clean before converting it. So an example of data that isn't clean. And for that, if you want to check the unique last code line. Oh, this is just hit and then D types. This is what you're referring to, SC. Yeah, it's just checking the data types, and then this is just checking the first row or any number of rows. Okay. So in a categorical column, let's say you want to check the unique values of within the column, you just call it unique. And running it, it will show you that these are the unique values. So an example of data that isn't clean is this. You see that Brooklyn, they mean the same thing to us, and Manhattan as well, but to Pandas, it's something different. So this is an example of unclean data. And so we can't convert it into a category yet. So we move on to neighborhood. So usually category data, we want it to have a limited, usually fixed number of possible values. But if we check the number of unique values within this category, this column, sorry, it tells us that there's over 200 categories. So that's too large for it to be converted into a category type. And it's good to keep it as an object data type. So let's move on to the third candidate to convert it into a category. It's this one. Yeah, sure, Ahmed. So it's recommended for category data type to have as few, like not a lot of unique values, because it's recommended to have only a few and not a lot. Like for example, over 200, that's too much, and you shouldn't convert it into a category D type. Does that make sense, Ahmed? Okay, cool. So let's move on to room type. So if you check the unique values, that's only 3. So this is perfect to convert it into a category data type. And I said that it can reduce memory. So that's what the get memory function is for. So when I get the memory of our data frame now, you see that it's around 6.26 MB. So to convert it into a category D type, all you have to do is type S type. And then it will convert it into a category D type. So when you call D type on this column again, you can see that right now it tells you that it's the categorical D type, and it even shows you the categories. And if you call the same unique function earlier, it even shows you the categories here as well. It tells you that there's 3 categories. And right now, when I get the memory of our data frame, you see that it reduced by around 0.3 MB. So that's what category D type is. Moving on to date time. So looking at this column last review, you can see that it's obviously a date data, but right now it's a string. So in order to convert string values into a datetime object, what we have to do is call the toDatetime function. And what we pass in is the column itself that we want to convert and the format. So right now we'll work on figuring out what the format of this is. So if you go into this link, it will show you a list of string formatting in Python. So our date was year, month, and day. So for our year, we see that there's 0 padding, which means there's a 2-0 in front of the year instead of just like 13. So our year will be a big case Y. And then for month and day, it's also 0 padded, as you can see. So this month is going to be this lowercase m instead of this because it's lowercase. I mean, because that's 0 padding, sorry. And then for day, it's also a lowercase d because that's a 0 padding. So from that, we can know that the format of our date time, it's going to be percentage y. So you need to include the percentage on each of them in front, and as well as the dashes because the format is a dash instead of like a slash. So it'll be a dash and then m and day. Sorry, I forgot a dash here. So this will be the format of our date that Python can recognize. So converting this into a date time. See, right now it says that it's M8, which also stands for date time. And if I call all the data types again, you can see that it says date time 64. So right now, our data types are pretty much fixed. And a cool thing about a date time data type, the missing values, they're actually represented as NAT, which stands for not available time, instead of NaN, which is not available number. So that's something different when you convert it into a date time object. Moving on to changing numeric types. So there are different variations of numeric types, such as that's int8, int16, 32, and 64. So these numbers, 8, 16, and so on, they stand for bit. So in int8, it only takes in the range of this amount of integers. So when you go higher in bit, you can store more integers. Basically, the bigger this value, the more size it will store. So if you want to convert it into a lower one, you can do that in Pandas, which I'll show you right now. So let's say we get maximum nights column and we get the maximum value of it using dot max. It's going to show us that it's around 1250. And if you get the minimum, it's around 1. So right now, this data type minimum nights, it's in 64. So since our maximum integer type, it's only going to be 1250. It's not necessary to store it as an int64 data type. So if you want to reduce it down into a lower level, such as int16, we can. So I'm going to show you that it reduces memory again by getting the memory right now. And then to convert it, what you need to do is call the astype function. And you pass in the type of the integer that you want. And right now it's going to show me that it's right now an int16 data type. And when I get the memory of it, it will say that you can see that it reduced the memory around 0.3 MB as well. So basically, if you want to convert numeric types, even between floats and integers, you can use astype. So now we'll be going into the big topic of missing data. In Pandas, if you want to track columns that have missing data, you call the isNull function. So null means missing again. And when you call isNull, and I print the first variables, what's it going to return is false and true values. So false means it's not a missing value, and true means the missing values. So if you want a better representation of this, because this isn't very useful to us, what you do is you sum all the null values up using the dot sum function. And if you didn't know, true in Python stands for 1 and false is 0. So when you call sum, you're basically adding all the true values, which is 1. So when I call this, it's going to show us that these columns, they have missing data. And this is the amount, total amount of missing data. And so here's where my custom function comes in, because all these other columns that don't have missing values isn't very useful to me at the moment. So what this will print out to me is only the columns that have missing data, the total amount as well, and then the percentage. So why the percentage can be useful is, let's say the missing data is over 90%, and that would signify to you that it's actually not a very useful column to include, and you may even decide to drop it because there's just too much missing data. Another way you can visualize missing data is with a heat map. So this is from Seaborn. And what it does is it basically maps out all these values of true and false and turn them into colors. So false, it will be purple, and then the true values, they are coded as a yellow color. So what this is showing me is these are the columns. So all these are columns, and then these yellow lines, they basically mean the missing data within your data frame. So this is useful to just show you how many missing data is present within your entire data frame. Yeah. So from this heat map, we can tell that last review and reviews per month have a lot of missing data, whereas listing name and host ID only have a little bit. So right now we'll be going into no, actually true is yellow and false is purple, I see. And good question, Stephanie. That will be what I'm covering later on. You wait for a while. Yeah. And we'll be going into how we deal with missing data. And I just want to say that dealing with missing data is not a simple task. You need to consider why the data is missing in the first place. It could be problems with how you collect your data or how you even build your data frame. And most importantly, you need domain knowledge to be able to know what to replace the missing values with. So as Stephanie asked, I'm going to answer it by saying there isn't really a specific threshold that is accepted because it really depends on your data. But let's say if it's like 90%, like it's a lot, then I think it's recommended to drop it. But it really depends on the data in the end. And overall, if let's say you mess up any imputation, which means you replace the missing values based on your own opinions, you're going to introduce bias to your data. So you have to really be careful with how you deal with missing data. So in this workshop, I'll only be covering 3 ways to deal with it. You either drop the columns, you drop the rows, or you replace it manually with your own values or automatically, which is from algorithms. And if you want more information about dealing with missing data, please just go to this article where you can go deeper into this topic and then check out this paper. So before we start with these operations, a good tip for when you're experimenting with what missing values to impute or some operations, it's good practice to copy the data frame so that you have stored the data frame at this point in time. And then if you mess up anything, you won't have to go back all the way and load it everything again. So this is a good tip for that. But I'm not going to run it now. So the first way to do it is to drop the column. So how you do that is by using the drop function. So drop function takes in the columns that you want to drop, the axis and the axis. So I can create a list and give it the names of the columns that I want to drop. So I decided to drop ID, hostname and host ID. And why is because from the Kaggle notebook, I saw that someone said that hostname is not ethical to include. So you should decide to drop it. And then ID is, let's say you're building a machine learning model, IDs aren't very useful features because they're just unique IDs. And overall, dropping columns is not a really good strategy because you're usually losing a lot of information. There's an exception of whether it's a lot of missing data or in this case, the features are just not useful. And by passing in the columns that you want to drop and then the axis as well, which in this case, it will be column. Since we're dropping the column, passing column here and running this, it dropped the column already. And you can see from the function that it went out to only 3 columns with missing data. And then printing the shape of the original data frame and the data frame now, you can see that the number of columns reduced by 3. Sorry, I didn't run this. Basically, it was from 16 and it became 13. So we reduced by 3 columns. So next method is to just remove the rows. So this is an even worse case, I would say, because you're losing even more information from other columns. So it's not really a good method. So, but how to do that is you just call drop NA, which means drop NA values. And printing this, you can see that if we drop all the rows to missing data, we lost over 10,000 rows of our data. So you're losing a lot of information there, so it's not really recommended to do that. So moving on to imputing. So this, I would say it's one of the best ways to deal with missing data, but you have to be careful with how you do it. So there are a few ways here that I would mention, which is filling it with a constant value. For example, the column's number of reviews or listing name. So an integer column, you fill it with an integer, or a string column, object column, you fill it with a string. And there's also other ways such as backward fill and forward fill, which I'll explain later. This could also be, corollary. Now, NA and null in Pandas is actually the same thing. So there's these two methods, is NA and then is null, which from what I read, it's the same. It does the same thing in Pandas. Hope that answers your question. Okay, so we can also decide to fill in summary statistics such as mean, median, or mode for the columns. And lastly, it might be an arbitrary value that was estimated by algorithms, ML models like k-nearest neighbors, and sometimes even deep learning algorithms you can use to impute missing values. So if you want more detailed techniques, you can check out this article I linked here. So to impute missing data with Pandas, you can use the fill NA function. I don't really use Kaggle that much, so I don't believe I'm ranked, Shubham. Yeah. So if you want to decide on what missing data to impute, you usually look at the values itself. So since this is a float column, we can fill in with a float value. And since this is a string, we fill in with strings. So here I've decided to fill in reviews per month with 0 and then listing name with none. And to fill it in, we call the fill NA function. And it takes in this dictionary where the keys are the column names, which has missing data, and the values that you want to replace the missing values with. So for my case, I set 0 to be what I want to replace the missing values with for this column, and none, and passing it to this function. You can see now that the missing value has been replaced with 0, from NaN to 0. And moving on to, besides constant values such as these, I can also use statistics such as mean and median to replace it with. So to get the mean of a specific column, you just have to call .mean. And what this will do is calculate the mean for you for the entire column. And we can straight away just fill this mean value by passing it here in this dictionary. You can see now that the mean value of 1.73, it's filled in here. It replaced the missing values. You can also just calculate median by calling the median function and do the same for here by passing in the median, and it replaced it with the median value. So that's filling NA with a value that you calculate or a constant value. Moving on to this bfill and ffill. So what bfill is, it stands for backwards fill, and it means that it will be filling the missing value with the value after it. After it in this case stands for the row below the missing value. Sure, I see. So bfill means filling the missing value below the row of the missing value, and then ffill means you're filling it before it. So I'll demonstrate it so that it's clearer here. So right now the missing value is at row 2. This line, I see. Which line do you mean I see? I'm just gonna move on. So hit, it will show that the missing value is at row 2. So using bfill, if I pass in bfill as the method to replace my missing values, you can see that it replaced it with the value after the missing value. So 4.64, which was after NaN, it replaced it on the null value. And then ffill is the opposite. It's going to replace it with the one before, which is 0.38. So this doesn't only work on numeric, it can also work on datetime columns. So for datetime, our missing value was here. So if I do ffill, it's gonna fill in with this specific data point. You can see that right now the missing value was replaced with this data. And you can even call ffill or bfill on the entire data frame, and it can, ffill function, and it can replace it on the entire data frame. And after you experiment with different things, you would end up with the best method or option that you can go with. And for fill NA, you can just call in place equals true as well, and it can update the data frame for you. And it shows us that the last column with missing values is last review. For my case, I'm going to leave date column empty with missing values because it makes more sense to leave it empty, and I don't want to introduce bias to it. But let's say if you have time series data, which really depends on date time, it's going to be a must to impute them, or else the data won't even work because it's cumulative. But moving on, so when you have a date column, what you can do is you can even split all these specific attributes into its own column. So for year, month, day, it can be a column by itself. So how to do that is you instantiate these columns as a datetime object by doing .dt. So what this does is it converted this into a datetime object, and then you want to get the year. So by calling .dt.year, and then as type integer, because when you split it up, it's not going to be datetime anymore. So I converted it into an integer. And for the rest, we just fill in month and day. So what this did is it converted the datetime into, it split the date column into its own specific columns. So looking at the head, you can see that we have the year, month, and day column right now. That's useful when you want to just visualize only the year or the month or the day. And move on now to data inconsistencies. So in data, your data, sometimes the columns, you have to make sure that they are within a specific range. So for example, the column availability 365, it has to be within 365 because it's a data where the column is the number of days when listing is available for booking. So that means throughout the entire year, how many days in a year is it available? And when we call describe, which basically just shows me a summary statistics of the entire column. As you can see, it shows me the count, the mean, and maximum, and so on. So from here, we can even tell that the minimum was 0 and the max was 365. So this means your column was correct. So there's no out of range data. But there's also a different way that you can test this. So Python has this assert keyword. What assert does is you're testing whether this condition that you pass it to, whether it fulfills it or not. So let's say I say 1 + 1 = 2. Python is gonna accept that condition because you can see that it didn't give me any errors. But let's say if I say 1 + 1 = 3, it's gonna be very angry because this condition obviously does not fulfill. So it's gonna raise an assertion error. So to test whether this column is within a range, you can do assert this column, the maximum of this column is less than 365, and I assert this condition. You see that both of them will pass. The minimum is more than equals 0 because the data was in range. And you can also check whether the latitude and longitude chords are valid. So a valid lat and long chord, it has to be -90 to 90 and -180 to 180. And even more specific, since this is a New York City data, it's going to be within a range of latitude and longitude coordinates. So calling describe, see that the values are ranged around 40 latitude and negative 73 longitude. So this is a New York City lat and long chord. So this tells you that it is correct. But if you really want to make sure, you can plot a plot of the map itself, and you can check out this notebook that did that. Basically, they took a map of New York City, and then they plotted the data points onto the map itself, and you can check whether the data points are correct. So we move on to categorical data consistency. And if you still remember our neighborhood group, there are some spelling errors in our columns, in our categories. And so assert is just basically just a different way to test. It's a debugging tool. So I wouldn't say that's an advantage to it, but just another tool that you can use. Hope that answers your question before. And so if you remember the neighborhood group, there's problems with our categories. So when we print it out, the unique values, you can see that Brooklyn and Manhattan, they have spelling errors, which causes them not to be grouped together. So how you can fix that is using Pandas replace method. So what you need are two things, the wrong spellings or the wrong values, and then the right ones. So creating a list of the wrong spellings, Brooklyn, Manhattan, and then the right ones. And you have to make sure that you map the right one, like Brooklyn to Brooklyn as well, because they have to be in order. So calling the replace function and passing in the wrong spelling, the value that we want to replace with the correct value, and then doing in place equals true. And see that we fixed the group already, because right now we have only unique categories. Okay, so usually that was a very simple example of inconsistent values. It's usually harder to deal with than this, but there are two ways that you can make it easier. First is you can pre-process the text so that, let's say, there's different cases of value, and what you have to do is lowercase all the values to keep it consistent. And you can also strip white spaces so that Pandas won't treat them differently. And the other way is fuzzy matching. If you don't know what fuzzy matching is, it's, let's say I search for this value on Google. So what Google did is it fuzzy matched this word as Brooklyn. So you can also apply this concept on fixing your categories. And if you want to see an implementation on this, you can check out this Kaggle notebook in this link. And it really makes it easier since, let's say there's over 200 categories and you don't want to check one by one, you can use fuzzy matching. So moving on to duplicate rows. To check for any duplicate rows that are not necessary, and it might have been caused due to human error, you do duplicate it and you call any. So without any, what duplicated just shows you are ranges of true and false values, where false means it's not duplicated and true means it is duplicated. And then calling .any, it will just tell me a Boolean value true, which is there are duplicated values in my data frame, and false otherwise. So to check how many rows are duplicated, you can call this .sum instead of .any. And it tells us that there's one row that is duplicated. You can even see which row it is that is duplicated to really make sure, or to look at it. You can just call duplicated as well. And what this is doing is, since this value is false and true, when you call df and you index this false and true value, it's only going to take the true value. So this will return the true value from this output, which tells us that it's this row that is duplicated. And to drop this duplicated row, all we have to do is just call drop duplicates, and then set in place equals true as well. So what it did is it remove the duplicate row first, and if you check whether there's any duplicate values, it's going to return false. So that's all from data inconsistencies. Now we're moving on into the last section, which is outliers. So what are outliers? Outliers are basically data points that is far away from other observations in our data. It usually arises from errors in our data collection, or it could even be due to some relationships between a few columns in our data. So it might be inherent to the data itself, and it could be valuable information. So there are two things. It's either these outliers are bad and you have to remove them because they're errors from data collection, or it's because, or they're actually useful to us and it tells us important information. So to detect and to differentiate them, you can use box plots and histograms, which is just visualizing the data, and statistical methods such as IQR, which stands for inner quartile range, and skewness to find out the outliers. And this quote is very helpful, which says that the best way to handle outliers is also to have good domain knowledge. So it's really similar with missing data. And you really have to understand where the data comes from and what they mean. And it depends on what kind of analysis you want to perform as well. So there's a few ways to deal with outliers, and I've linked a few articles here for you to dive in deeper into that topic. So right now we'll look at an example of outliers for continuous data. So for our price column, we can call the describe function to show the stats of this column as well. You can see that the mean value is at 152 and the max is 10,000. So if this doesn't really show us blatantly that there is outliers here. So what you can do is call a histogram. It can show you the skewness of your data. So this shows us that it's very right skewed. And then there are some data points around this area, but they're too small to be visualized. This tells us that there are indeed outliers, but to really be sure, you can use a box plot. If you don't know what a box plot is, so this line will be our median of the data. This is Q1 and Q3, which is the percentile. And these two are the minimum and maximum, which you can calculate from IQ, from our percentile and from the interquartile range. But basically, any data points that is outside these two lines, the minimum and maximum, they are categorized as outliers. And if you want to plot a box plot in Pandas, you just have to call df.boxplot and set the column you want to plot as price. And running this, it will give us the box plot. From here, you can see that a lot of our data points is outside of the two lines. And this really just shows that there are a lot of outliers in this column. And I didn't include how you can deal with them, but you can go deeper into how with these articles that I think. And now I'll move on into categorical data. So to plot out categorical data, you can use the bar plots, but there's also a way in Pandas called value count. And it can show you the counts of each category. But since this isn't a very visualizing way of seeing it, you can do dot plot, you can do dot value counts. This calculated all the total counts. Then we can do dot plot, and then we can do dot bar. So what this does is it plots a bar plot based on these data. So running this gives us a bar plot of each category. So let's say, so this, in our case, this isn't really outlier data because it makes sense since Manhattan and Brooklyn, they have a higher housing density, and it will make sense that they have more data points compared to these other areas in New York. But let's say if you want to compile these three categories into a singular category, you can actually do that in Pandas. So I'll show you how right now. So the value counts, you want to grab these three categories. So what you can do is you index them by setting 2 to nothing, which is the last one. So by setting 2, which is Queens to Staten Island, and then you want to grab the indexes of the column so Pandas know which rows you're referring to. So by doing .index, I've saved up the indexes of all the values in these 3 categories. And then in order to replace the category with something else, I can use the df.log, which log stands for location, I believe. It's to index the data frame by rows. So since all the index that are within these 3 categories is saved in here, I'm telling Pandas that for all the rows in this column neighborhood group that is inside this index, I'm going to grab it. And then for this category, I want to change it to other. So this is what it's doing. It's changing all the category into other. And when I do have value count now, you can see that it became other. So all these 3, it was grouped into a singular category. And when I plot a bar plot again, you can see now that it might look a bit less skewed, I would say, because there are more data points in the other categories. And right now, since we finished working with the neighborhood group data, we can finally convert it into a category because we finished cleaning up the column, and we can call as type category. So after you finish all your data cleaning, you can even save up the version of your data frame into a CSV file using the toCSV function. And calling this, it created a CSV file for us with all the clean data, and you can download it right here. And this is the end of my workshop. Go back to the F field. Oh, sure. So F field, it's here. Yep. Do you have a question on this essay? Ahmed asked, have you transformed categorical variables into binary? Oh yeah, I have not, because that's more towards data transformation, I would say. But I believe you're referring to one-hot encoding, right? So yeah, one-hot encoding, what Ahmed means is, one-hot encoding is you're turning categorical variables into ones and zeros. So I didn't cover that here, but it's also a useful, I mean, it's also required to do so for machine learning models to understand categorical variables. Output and text. So in order to only grab the Python, I believe you can just go here and download .py. Yeah, Somesh, I hope this answers your question. So all this data was from Kaggle design. You can easily just get all sorts of data from Kaggle, and you can practice on these data sets and to really improve your skills. So let's say you go into this data set, and you can even check out, go for a more popular one. You can check out the implementation of other people, and you can really learn a lot by just looking at how people approach the cleaning the data, exploring it, and building a model from Kaggle. Yeah. Yep, this modified file, I will download it later on and share it on GitHub, and you can find it here, Stephanie, Lisa as well. So I think that marks the end of this workshop. So I just want to thank you everyone for listening and paying attention. I'm sorry for the mishaps and for the workshop not being so smooth, but you can reach out to me on LinkedIn, and you can find my articles on Medium. And as I said, everything, the material is within this repo. Thank you, everyone.
Cool. Thank you so much, Ben. It was amazing workshop and congratulations with your debut. Cool.
I have another question from Somesh. Is this not remove the output and text? Oh, it doesn't. I'm not really sure how you can only get the code and remove the output. But this one only has the text, so maybe this one. I mean, maybe this works for you. Downloading.py. Yeah. Thanks so much.
Cool. Yeah, guys, if you have your last questions, there are some questions about the recording, about their files. I think we shared it a lot in the chat, and also I shared it as well, a link to the notebook. The link to the recording will be shared on your event page, probably in a couple of days. So just guys, keep a track of the event page that you have been registering for this event, and we will post the event, a link to the recording very soon. Cool. Then maybe you can also post link to your Medium articles.
Yep. So here's an example of the article I wrote on data cleaning. You guys can check out, which inspired this workshop. And you can check out all my articles on the bitgrit data science publication here.
Cool. So yeah, I encourage you guys strongly to learn data science, to get better at data science, maybe to participate in some of the bitgrit competitions, and maybe even win some prizes. That's gonna be really cool, and it's gonna be really a cool peak of your career as a data scientist.
Watch out for competitions upcoming on bitgrit. You can find it all here. Yeah.
Cool. Or if you want to keep a track of the competitions, I recommend you to subscribe to the bitgrit newsletter. bitgrit usually sends the latest updates about the competitions via newsletter.
A lot of resources in our newsletters.
Cool. So if we have no other questions, we will probably wrap up the workshop. Just want to say thank you. Okay, question from Nora. Question from Nora. Nora wants to get a complete file.
So you can find the complete file here. And if you only want the Google Collab notebook, it's here.
Cool. Okay, just given 30 seconds to guys so they could click the link and open the GitHub repo. Cool. So yeah, probably wrapping up the event. Just wanted to say thank you to Ben and congratulations. It was a really cool workshop. You did well.
Thank you.
Also wanted to say thank you to the whole bitgrit team. Thank you so much, guys, for delivering such insightful, such an interesting workshop. I really appreciate collaborating with you. Okay. We have people randomly unmuting themselves. It happens. Thank you so much. And yeah, I just wanted to say, if you guys are interested in data science, follow Wagon for more data science related workshops. And as I mentioned, we will have a data science demo day coming on July 30th, where our data science students will present their deep learning solutions built during the bootcamp. And it's actually incredible because people come to the bootcamp, they have no idea about data science before joining, and then they go through the bootcamp and they become data scientists. And I'm looking forward to seeing Ben joining us, maybe for upcoming workshops, maybe delivering more interesting topics. I'm looking forward for interesting ideas from you, Ben.
Yeah, for sure. I'll definitely do it. Yeah.
Cool. Great. So yeah, good evening for those based in Japan and Asian zone. Also, we have people based in Colombia. So good morning, Stephen, and good afternoon, maybe for those one who are based in Europe. It was nice having you all, and thank you so much for so many questions. Cool. Thank you so much, Ben. You're amazing.
Thank you, everyone.
Bye-bye.
Bye.